All right, so other questions. Did you have something else on the operator question?
No.
Okay.
Not really.
All right.
Would you recommend us to pull code from the first project that we did, the faction 1 at all?
So somebody asked the other day, I thought it was this section, maybe it was the morning section, if I would let them implement a calculator that does fractions. And I think that's a cool idea. I didn't want to spec that out as part of the assignment because there's a lot of details that need to be addressed in that. But if you're interested in doing a calculator that does fractions, talk to me about it, and we'll pin down exactly what that means. But other than that, probably nothing from the first assignment in particular would translate over. I mean, you might make some two-string methods and stuff like that, but I'm not sure anything would actually carry over. And doing the operations for the calculator in PA3 is probably just a switch statement or a set of if statements. If the last operation was plus, then result equals num1 plus num2. If it's minus, it's num1 minus num2, that kind of thing.
I mean, like, isn't that kind of opposite? If we're working with a calculator that's accepting fractions, we kind of want it to do the opposite of what our fraction Java program did, right? Because if I'm thinking in terms of pure mathematics, if we're working with a logic-based system, we want to use exact values whenever we can. So wouldn't we want it to pass it as these fractions and not change it into the floating? And then, like, the very last thing should be, all right, now divide these full numbers. And
that's where you get intricate and add a button that converts decimals into fractions.
Yeah.
So like you can, depending on what you want. So if you put in a fraction, you can like switch a statement that says decimal is true or fraction is true, and if fraction is true, it prints out the fraction of the number, or if decimal is true, it converts the fraction into a decimal.
Right.
Well, I was thinking more of like error propagation, for example. If you took the fraction, accept fractions, and then start doing calculations with them, wouldn't your calculator be of higher quality if instead you took this fraction and you said, I want to square 2/5? It would be a higher quality calculator if you said, all right, I'm going to square 2, and I'm going to square 5, I'm going to divide 2 squared by 5 squared, and then I'll convert it into a decimal.
So my ideal for a fraction calculator would be don't do decimals, do fractions. So have a horizontal line button, and if I say 1 horizontal line 3, that's the number 1/3. So if I say 1 horizontal line 3 plus 2 horizontal line 4 equals, and it would show me in fraction form 1/3 plus 2/4, right? And then there could be a button to say, okay, convert this to a floating point number. And if my number was 2/5, then I'd see 0.4. But it would actually keep things in fractions because then you don't, have the rounding off and stuff like that. And yeah, I think that would be a higher quality calculator.
When you're creating a program, do you ever like see like mistakes you made and then just scrap it and want to like start over, but like still have it? Okay.
Sure.
That's like the third time I've done this.
Yeah.
How do you, because like when you're going over both the like midterm or the final for last quarter and this going over what you wrote for PA2, there's this difference between like when I write a program and I work it out step by step and then I have the finished product, I see those mistakes and like I want to go back and fix them, but like how do you get it in your head that you just like do it right the first time when you're like, because you may not be working with thinking about those edge cases at the beginning. How the whole interacts is different than how each of the methods interact. So how can you write the big picture stuff correctly the first time?
Maybe you can't.
Yeah, I feel like there is no way, because that's part of like doing like actual writing your own program. Is like once you're done, you revise it, make sure it's perfect, and then if it's not, you sit back, see what you need to do, and just reconstruct it based from there.
Yeah, so one of the 3 pillars I say to being an excellent programmer is rapid prototyping, right? Being able to get something up and running like in a few minutes, even if it's nothing like what the final product's going to do and it's got all kinds of errors and edge cases and stuff like that. If you can get something up and running with minimal effort and start building from it, for me, that's more productive. right? That's just personal style, right?
So basically, it pays not to be a procrastinator.
But for some people, I suspect it's more efficient to sort of work out more of the details in your head and then start writing and be closer to the finished product on the first draft. It's an individual thing. But you know, I've got some software that I wrote 30 years ago that I'm still using today. I've got some software that I wrote 2 years ago that I've changed 6 times and it's still not right. It's just kind of, and you know, maybe I don't care that that's the case. Maybe I didn't care about nailing it down perfectly. I just wanted something that would do this piece of a problem for now, and then year later, it's like, well, but it really has to do this other stuff too. And maybe you can modify it and augment it, or maybe you have to start over from scratch. Or maybe you abandon the whole programming language and start with something new. It's all good. Do you have a question?
I did. So we have an 85 point max on the functionality.
Mhm.
What happens if we do 100, but 15 of those were incorrect? Would you still go with the 85? Or
So I'm going to add up all the points, and I'm just going to clip it at 85.
Okay.
So if you get 100 points, but you get a 15-point deduction, you'll end up with an 85.
Okay. All right.
Yeah.
Thank you.
That would be pretty evil to do it the other way. So thanks for the idea. All right, I think black on white works better for visibility. So I'm going with black on white. If it's not good, let me know. Okay, I'll make a temp. All right, so I want to talk about, what do I want to talk about today? I think I want to talk about file and linked list. Yeah, good. Okay. I want to talk about input and output from files, first of all. So we can read from standard in using scanner, right? You construct a scanner and you can use next line and has next line, or next and has next, and so on. If we want to read from a file, we can do almost the same thing. There's a class called file. And we can construct a file by just giving a path name. So name of a file, and once we have a file object, we can do all kinds of things, like for example, check to see what the permissions are on that file. Can we execute it? Can we read it and write it? We can delete a file by calling the delete method. We can see whether or not a file exists. We can find the absolute path name in case we used something from our current directory. We can get a full path name to it. And other things like that. So let's play with this. It's java.io, that file. So I'm just going to say file f equals new file testing. And I run that and it doesn't do anything. I constructed my file. I don't have a file in here called testing. That's okay. You can still construct a file object with any file that you like. But we have, for example, an exists method once we have a file object, and we can call that, and it will give us a Boolean telling us whether or not the file exists. So in this case, it returned false. So I can make a file called testing, and now if I run this, the exists method returns true. And we can check permission bits and things like that. I could delete it, but then I'd have to type it in again. There's also a method called list. So if you look at list, list returns an array of strings naming the files and directories in the directory denoted by the path name. Let's play with the list method. So I'm just going to say f.list, and it's going to give me an array of strings. And if I have an array, I can look at a field called length that'll tell me how many things are in the array. So I can print out f.length. Well, if I go ahead and I run this, it's not f, it's names. If I try to run this, I'm going to get a null pointer exception, because testing is not the name of a directory. Testing is just a plain old file. But if I do this on, say, dot, which is my current directory, and I run this, it tells me number of files in the directory is 3. There's my 3 files. If I do this on dot dot, it tells me I got 33 files. That's what's in my parent directory, dot dot. And there's other things we can do in here. For example, there's a method called isDirectory, which tells us if the file we've constructed corresponds to a directory. So we could take, yes?
How would you do this on, say, like Eclipse to check for files, because there's no directory that you're in?
You are in a directory, though.
You are?
Yeah.
Because I tried running it and nothing happened.
You're usually sitting in the bin directory way down in the path where you started your project. But it takes some snooping around to figure out where you are. But we're going to talk about how to create files in a moment. You can create a file, or you can just do a list of files and see if you can figure it out from there. There's also system calls you can use to see what your current directory is, and you can print those out, or to change it. So let's go through every file in dot dot, and let's see which files are directories. So let's make a new file out of dot dot slash plus names bracket I. So names bracket I is just the name of that file. We'll put the dot dot slash on front of it to point to our parent directory, and we'll pass that as a constructor to file. So this creates a file corresponding to each of the files in our current directory, and then we can say dot is directory, and if it is, we'll just print it out and say it's a directory. Yeah. Otherwise, it's not a directory. try that. Alright, so book 223.pdf is not a directory, ideas is not a directory, network is a directory. And you could cobble this into a nice little recursive traversal program. If you wanted to see every file in a directory tree starting from some point, you could make a little function called, display everything from this point on down, and you pass it a path. And it could construct a file, go through each of the files in that directory, and if it's a directory, it could call itself with that path. And when it gets to network, it would start running itself on the network directory and print out all the files in that, and then come back and do the same for net, and so on and so forth. So this is a very useful class, this file class. And it's also useful because we can use it to construct a scanner. So let's open our file called testing. Alright, so we construct a file object, we can construct a scanner using that file object, and then we can say, well, the scanner has another line, let's read that next line, just print it out in a loop until it has no next line, and then we'll just close the scanner and be done. And instead of reading from standard in, it will read from the file testing, assuming it exists. So if you try to compile that, you'll get an error saying that scanner might throw an exception when you try to construct it. If you construct with system.in, you can't get an exception, but on a file object, it might give you an exception, in particular if that file doesn't exist. So we got to use a try-catch block. So I'll try to open the scanner in a try block. If something goes wrong, I'll go into my catch block. I'll print out the message, exception while opening file. I'll print out the value of E, which will tell me what the exception was and where it occurred. And then I'll just return from my main method. And this looks pretty good. And it will almost compile. But it's going to complain that it doesn't know what SC is. And this is down at line 17. So if I go to line 17, this is where it's complaining. Why doesn't it know what SC is?
Because it's compiled internally?
Yeah, SC is defined to be a scanner, but it's inside this set of curly brackets. So once I leave this set, SC no longer exists. And I can't get to it down here. So the easiest fix for that, just declare it outside and then assign it a value inside your try block. Since I declared it outside of the try, it exists outside of the try. In fact, it exists everywhere in this method. And I'm just giving it a value inside the try block.
Could that give you a null pointer exception though?
So if I didn't have a return here, I will get an error saying SC might not have been initialized.
No, but I'm saying,
Which is a null pointer exception in the making.
yeah, okay.
Right? But if I have a return here, it's not going to give me that error, and in this case I cannot get a null pointer exception because I give SC a value, right? And if I don't return in the catch block, SC must have gotten a value. Now you have to know that scanner's not going to return null, and we don't necessarily know that, but I trust it.
Okay, yeah, because that's what I was thinking, is even though we have the try and the catch, if we try and it doesn't let us make a new scanner and we return, that scanner is still like initialized to null, isn't it?
If we return, then that SC is completely garbage collected, because once we leave this method, SC
okay, I see.
goes away. Now if we had SC as a class variable, right, so if we did this, right, then we might come out, forget that it's the main method, if this was some other method, we might come out of that and SC would not have been given a value and it would still be null. But even at this point, if we try to use it, we get an error from the compiler saying it might not have been initialized. You can make that error go away by setting SC to null, but then SC might be null at some point.
Does the garbage collector, is it only running because you're returning from main, or does it run
It
every
runs
time?
all the time in the background.
So every time you return from a method, it'll garbage collect that?
Not necessarily. I don't know what the scheduling looks like for that. And it's probably implementation dependent. But it should run periodically or, sporadically in the background and pick stuff up. And it may be based on how low the memory is. That might cause it to run off schedule and so on.
Can you force call it?
Yeah, you can.
Okay.
I don't remember how. If there's a way to say go ahead and start. It might be system in the system class. Alright, so this should work fine. Go ahead and run it, and it reads the contents of the testing file. If the testing file doesn't exist and I try to run it, I'll get an exception. In this case, it says no such file or directory. If the file's not accessible, like if I give it a permission of 0 and I try to run it, it'll give me an exception and it says permission denied. So different things can cause exceptions. Those both show up as file not found exceptions, which is kind of interesting. Alright, so scanners are useful for doing input, and they work exactly the same on a file as they do on standard in. You just construct them with a file name from a file. And then has next double, all that sort of stuff works exactly the same. So that suffices for doing a certain amount of input. Right? Scanner works well for that. There's other ways to do input. There's lots of different classes for doing different styles of input. Some are more efficient than others. Some do things like convert to doubles automatically. Some are very low level and just read byte, 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 byte. And you have to do all the translation and interpretation yourself. But for a first order, this is fine if you're trying to read input from a user. The output direction is even simpler. So there's a class called Printwriter, which we can use to create something that we can basically write into. So we can construct a Printwriter with a file, or we can construct it just with a file name in quotes as a string. And once you have a Printwriter, we have, among other things, print methods and print line methods. And everything we can do with system.out.println or print, we can do with a Printwriter's println or print. Plus we can do formatting in the style of C code. We can close the output stream. We can force it to shove its buffered output to the actual output, and so on and so forth. So let's play with Printwriters. I think that's right. And when you construct a Printwriter, let's look at the constructors. Printwriter from a string, it can throw an exception, which is file not found exception. And it can also cause a security exception if you don't have permission to create the file. So constructing a Printwriter has to go in a try-catch block also. And I'm going to be lazy and I'm just going to put it inside the same try-catch block. I'll make a weird file name with spaces in it just because I can. Okay, so instead of printing this output to standard out, let's go ahead and just write it to our Printwriter. I probably want my file to be readable. Okay, so let's go ahead and run that. And it created a file called my new file, ha ha ha. But that file looks like it's empty. And in fact, it's got nothing in it. Even though we wrote a bunch of stuff into it. The problem here, remember that most of this file I/O is buffered. So when you write something to a file from a program, it doesn't usually end up on your hard drive right away. It goes into a buffer, a holding area, until you've got enough stuff in there to make it worth the effort to actually write it out to the disk. Once that holding area is filled, it'll say blah, and it'll dump it all onto the disk in one fell swoop, and it's much more efficient because it's very expensive to write things to an output device like that. You have to wait for the disk to spin around, you have to move the read-write head, and so on and so forth. But you can force it to write by saying flush, or you can say, okay, go ahead and flush out the contents of that by closing it. And closing it is actually the right thing to do. So we're no longer using that Printwriter call close. That'll force this holding area, this buffer, to get written out to the disk. So now it's got our output in it. And that can be one of those annoying 2 a.m. bugs where your output's not coming out and you think it's something deep in your logic and you're ripping apart all the code you spent weeks writing, and it's just because you didn't close or flush the output. So don't do that. All right, questions on that? Again, there's lots of ways to do output. You can do unbuffered output, you can do very low level output. Printwriters are very sort of high level cooked output forms, so you can take a double and concatenate it to a string and it'll format it correctly and send it out to your file and it'll look beautiful. Great for quick input-output operations, kind of like scanf and printf. That's kind of like scanner and Printwriter. If you want to do low-level stuff, there's other ways we can do that, and we'll talk about that later, probably around PA5 when we're doing reading and writing to and from network devices.
So just to be clear, you can use flush or PW flows interchangeably here?
I think if we used flush, it would actually force it to come out. Yeah. But in general, you want to make sure you close your file when you're done with it.
Okay.
Because on some systems, if a file's open, other things can't read it, and other things definitely can't write it, and so on. But sometimes you want to write some stuff to the buffer, but you still plan to do more writing to it, but you want to see what you've written. That's where you can call flush.
Okay.
If you don't close it and you're working in a system where the main company uses Office 365, the entire company will riot and fall to the ground.
Yeah. Which might have happened anyway from the scenario you described. All right. So, temporary change of gears. So, I made an announcement in the beginning of the quarter, that there's a student in class who is looking for a note taker, and we had some volunteers, and that doesn't seem to have panned out lately. So I'm wondering if we could have another volunteer for somebody who would take notes for this student. And the setup was, if you take your notes, you get this really cool carbonless copy paper, and you basically take your notes as usual, but then when you're done, there's a copy of it, and you can pass that on to the student. And so it's very easy for you. Or if you don't want to use that paper and you don't mind taking your notes to the DSS office or by Geyser Hall, they'll make copies for you for free. So is there anybody in here who would be willing to take notes and share them with a student? And if not, or if you want to find out more about this, you can come and talk to me and ask me questions, or you can talk to the Disability Support Services office in Pub 013 to get more information. Or if you take your notes online already and you don't mind just sending a copy of those, that works also, I believe. So think about that and let me know if you want to help out. All right, so we got scanners for input, we got Printwriters for output. And this is part of the general direction we're going next, which is to start looking at some of the other classes that are available for us in Java. And I want to start with a class called LinkedList. So LinkedList is part of an abstract sequential list, which is part of an abstract list, which is part of an abstract collection, which is an object. So extensions of extensions as usual. But this implements a linked list like we've been talking about in 222, like we've been using in 222 and 223. Constructor is straightforward, it's just linked list, no arguments necessary, unless you want to create a list with some initial objects in it. So just new linked list, paren gets you a linked list. And once you have a linked list, you can do the following things. You can add an item to the end of the list with the add method. We can add to the beginning of the list with the add first method. We can also add at a particular position in the list by specifying an index. So add, and we can put in an index and an element. We can remove all the elements from the list. We can ask, does the list contain a particular type of a particular element? We can ask for the element at some particular index. So even though it's a linked list, we can use it like an array, right? That we don't have to specify a fixed size on. We can keep adding things. We can add things at particular indexes. We can get things from particular indexes. We can also say push and pop. If we want to use this list to implement a stack, we can say push, and it will put it somewhere in the list in such a way that if we say pop, we'll get back the last thing we pushed.
Quick question. Would a linked list be best for creating, like, say, a sample program of the infinite, like, hotel problem? Or is there another?
Probably better than an array,
Is there?
because arrays are limited in size.
Yeah. Where with like linked lists, you can just keep on adding on.
You keep adding until you run out of memory, yeah.
Yeah. Okay.
Pop notice can throw an exception, no such element exception if the list is empty, so that's a stack underflow. And also remove for removing the first element in the list, so we can use a list as a queue. We can see how many elements are in the list. We can also change the whole list into an array, or we could take an array and turn it into a linked list. So the linked lists we've been talking about have been a really sort of narrow band of possibilities. They're little boxes with integers and arrows, right? But they're really a much bigger space. And the interesting thing is, how is this linked list implemented internally? Got no idea. It could be little boxes with arrows. It could be an array. Could be some kind of array that when it runs out of space, it makes a bigger array and copies everything over. It could be writing the stuff out to a file somewhere, and when you want the fifth element, it just does 4 reads, and then the next read it returns the value to you. It could be, you know, sending text messages to someone in a shed somewhere on the other side of campus with a big whiteboard who writes down things when you add them and types them back in when you read them. And none of it will change the way that we interact with this, right? When we want to get the fifth element, we would say get 5, comma, right? And so this is encapsulation, right? We don't tinker with the stuff below this level. Stuff happens down here to make these methods do what they say they do. But we don't need to know, and we're in some ways not allowed to know, how those things are being implemented. Now we can go get the source code and answer these questions, but it shouldn't make any difference to us. And if the next version of Java comes out and they switch from using you know, a dynamically allocated collection of nodes to using unicorn dust, we don't have to change our code, right? It'll just all still work exactly the same. We don't even need to recompile our code because we're just going to use this class.
You got an invert Java.
I do. Thank you. All right, so let's construct a linked list. Let's add some numbers to it. And let's see what it looks like. And I'm going to be hopeful that LL has a reasonable two-string method. Maybe it doesn't. I'm going to ignore the warning message I get from my compilation for a moment, and I'm just going to run this with great faith, and hey, looks like it did something good.
It looks like an array.
Looks like an array. So it's a comma and space separated list inside square brackets. But it's certainly got the numbers that I added, so it looked like add. Put these things on the end of the list. And, you know, we could have used this in PA2 and saved some time in our location list, if that was allowed. In fact, you could just replace location list with linked list and replace add to end with add, and you're done. All right, well, what about this warning up here? Unchecked or unsafe operations doesn't sound good. Recompile with -xlint, unchecked for details. So lint is a term going back to the early days of Linux. You could run your code through something called lint, and it would tell you about the things that weren't quite full-blown errors or warnings, but things that weren't exactly 100% right. Things that looked a little suspicious, but you could get away with it. So kind of like sub-warnings. So you can do the same thing with Java. So you can say -xlint, and you get lots of details on things you're doing that may not be right. And the main warning here is found raw type linked list, missing type argument for generic class, linked list angle bracket E, where E is a type variable. Well, what does that mean? Go back to the documentation for a linked list, and it says class linked list angle bracket E, and it says E is the type of elements held in this collection.
So you have to set each value so you can store strings or different types of
So yeah, you have to specify what E is to say, do I want to store integers or strings or something else? And this is this idea that we looked at before, where a linked list of strings, a linked list of integers, a linked list of doubles, the code's almost identical. The only change is somewhere in the code, instead of saying string, we say int, or we say double, or something like that. So linked list is a class that's generic. It can work with lots of different types, and the way you tell it what type is you put angle brackets with the name of the class after you say linked list. So that compiles just fine, and you run it and it does the same thing. But now, if I change this to a string, well, I can't compile it anymore because it's looking for strings and it doesn't know how to change these things into strings. Got 67 lines of errors for that. Alright, so we can call the add method with some strings instead of integers. And now we got a linked list of strings. And we can do this for pretty much any objects we want. We could make a linked list of fractions using our fraction class from PA1 by just saying linked list angle bracket fraction equals new linked list angle bracket fraction. And then we could add a fraction type object and we get a linked list of fractions. And I'm pretty sure when it's trying to do the toString method, it would call the toString method on each of these objects in the linked list. So if we have a toString for our fractions, it should come out the correct way. Or we could have a linked list of rectangles, we could have a linked list of word lists. And you could read in 100 different sets of text and turn each one into a word list and put them in a linked list. And it's no harder than constructing a list and saying add or get or delete and so on. All right, so there's a peculiar method in here called clone. And clone makes a copy of the linked list, but it says returns a shallow copy of the linked list. So I want to talk about that tomorrow, tell you what we mean by a shallow copy versus a deep copy, just because it's something that will come up at some point sooner or later, and it can be really confusing when it pops up. So we'll talk about the clone method, and then I want to talk about hashes. And that'll take us into talking about iterators, and we'll go from there. All right, so I'll see you tomorrow.